Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry question. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We have the points AC and D are vertices of triangle ACD with point B on the line AC. The first part of the question says, if points ABC are collinear, find the value of A. Note that points are said to be collinear if they lie on the same line. So for example, if I have a straight line and I have the points ABC, what it means is ABC are collinear if and only if the gradient of AB is equal to the gradient of BC, which is also equal to the gradient of AC. So we have ABC are collinear if and only if the gradient of AB is equal to the gradient of BC. I'm going to start with the gradient of AB. So the points I'm using will be the coordinate of A and the coordinate of B. I'm going to tag that. I have x1, y1, and x2, y2. So going to the gradient, starting with the gradient of AB, the formula is change in y divided by a change in x, which will be change in y. We have y2, which is a plus 2 minus y1, 3, divided by x2, that's 2a minus 11 minus x1, that's negative 2, so I'm going to put that in a bracket. So therefore, the gradient of AB is equal to, for our numerator, a minus 1, that's plus 2 minus 3, and then for our denominator, that will be 2a, then I have negative 11 plus 2 is minus 9. The next step is to calculate the gradient of BC using the same formula for the gradient, y1 minus y2 minus y1, that's change in y, over change in x. Then I'm going to change the coordinate. Now I'm using B and C and tagging that's x1, y1, x2, y2. Putting in the values, let's start with y2, which is 3 minus y1, it's negative 1, so I'm going to put that in a bracket. Then x2, negative 2 minus x1, that's 4. Therefore, the gradient of BC is equal to 3 plus 1 at the top, that will give me 4, divided by negative 6. Simplifying for that, that's minus 2 over 3. So therefore, we need to equate MAB and MBC. So we have a minus 1 divided by 2a minus 9 equals negative 2 over 3. If I cross multiply, what I will have is, I have 3 times a minus 1 will be equal to negative 2 times 2a minus 9. If I expand the bracket, the number outside multiplies the terms inside the bracket. So I have 3a minus 3 equals negative 4a plus 18. And collecting like terms, I have on my left 3a, I move my negative 4a to the left, it becomes positive 4a equals, then I have 18. If I move my negative 3, it becomes a plus 7a equals 21. And to find a, I'm going to divide both sides by 7. 7 is 7, 1. So therefore a equals 3. So for the first part of the question, the value of a equals to 3. The next question says, determine the equation of the line AC. The formula for finding the equation of a line, the standard formula, one of them is y equals mx plus c. Note that in the first part of the question, we're able to calculate the gradient, which is m. We have that as -2/3. And because we are trying to find the equation of the line AC, I'm going to rewrite my equation. That will become equals -2/3x plus c. I'm going to pick any of the coordinates of A or C in order to find the value of C. So using the coordinates of C, we have C is 4, as x is 4 and y is -1. I'm going to substitute that into my equation. This is my x and this is my y. So I have -1 equals -2/3 times 4 plus c. If I work that out, I have -1 equals -8/3 plus c. Therefore, c will be, if I move my -8/3 to the left hand side, it will be +8/3 minus 1, which is 8/3 minus 3/3 to make the denominator the same. So c will be 5/3. So therefore, the equation of the line AC will be y equals m, which is -2/3, x plus c, 5/3. For the third part of the question, we have to determine the coordinates of the midpoints of AB. In order to find that, we start with the coordinates of A. We have A, 2a minus 11 for our x, and our y is a plus 3. The first part of the question, we're able to get the value of a to be 3. So we have the coordinates of a will be 2 times 3 minus 11 for our x. And then for our y, that will be 3 plus 2. I'm going to correct that. It's plus 2. So that's 3 plus 2 close bracket. So therefore, the coordinates of A is 6 minus 11. That's -5. And 3 plus 2, 5. To find the midpoint, we need to find the midpoint of AB as shown. The formula for the midpoint, we have mid of AB equals, for the x coordinate, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Putting in the value coordinates, we have for B, that's going to highlight that, that's a coordinate for B. So we have -2 plus the coordinate of the x coordinate of A, that's -5 divided by 2. Then I have y1, 3 plus the coordinate, that's 5 divided by 2. So we have mid of AB equals -2 minus 5, that's -7 divided by 2. And for a y coordinate, 3 plus 5, that's 8. 8 divided by 2, that's 4. So the mid coordinates of the midpoint is -7/2 and 4. The last part of the question says, determine the value of P if CD is parallel to the x-axis. Note that if we have CD parallel to the x-axis as shown, what it means is they're going to share the same y values. So therefore, I have the coordinates of C, which is 4 and -1. Then the coordinates of D is 4p, then p minus 7. With my explanation, they have different x coordinates but the same y coordinates, so I'm going to equate that together. What it means is negative p on negative 1 is equal to p minus 7. P minus 7 equals to negative 1. Moving my negative 7 to the right hand side, p equals 7 minus 1. Therefore, my p is equal to positive 6. Thanks for watching. Bye.